All right, so 4.4, we have joint probability. So joint probability is the intersection of two events. So you're going to see the word and. And then you have two different formulas for joint probability. So P, A, and B. And you have to ask yourself, okay, are the events not independent or are they mutually exclusive? So you have to ask that. Okay. So for P, A, and B, you're going to have probability of A given B times the probability of B. And then for two independent events, you're just going to multiply. So probability of A times the probability of B. And then for two mutually exclusive events, meaning that they cannot occur at the same time, probability is 0. So okay, so let's do some examples for these before I get to this one here. So I want to do an example for the joint probability. I think, did I have one in here? I thought I put a union one in here, but I might have moved it. I did. Okay, so let's talk about cards here. Okay, so when we say mutually non-exclusive, that means that they can happen at the same time. So find the probability that, let's see, let me think of an example here. The probability that you have a 5 and probability of a 5 and a, not a 5 and a jack, that would not work. A 5 and a red. Okay, so this would be an example. So I have a deck of cards, and I want the probability that I pull a 5 and that it's red. Can that happen at the same time? Yeah, it can happen at the same time. So this is the formula that I'm going to do. So find the probability. You're going to do probability of A given B times the probability of B. So the probability of A is going to be that it's 5 given that it's red. Okay, so A given B would be this. Find the probability that it's a 5 given red. So 5 given red. How many red cards are there? 26. Out of those 26 cards, how many of them are 5? 2. There's 4 5s total, but 2 of them are black. Okay, find the probability then of event V, red. Find the probability of getting a red card. That's 26 out of 52, right? Or 1/2. Multiply them together. So 2 out of 26 and 1/2. Well, I'm just going to take that, multiply it by 1/2. So times, delete. There we go. Times 0.5. There's the probability. So 0.038. Okay, so we multiply 2 over 26 by 1/2, you get 0.038. An example for two independent events would just be given, cards wouldn't really work. Well, it would be independent each time. So it's like two separate events. Okay, so upon the probability that I get a heads and then I get a heads again, or something like that. So the example here, we could do 2 cards or 2 draws and, or sorry, 2 flips. Keep going back to cards here. So probability of heads and heads. So probability of heads is 1/2. Probability of heads is 1/2. That's going to give you 1/4. 0.25. So you don't have to worry about that because they're two separate events that do not affect each other. And then an example for this one would be find the probability that I get a 5 and a jack. On one single pull of the cards. Okay, well that's not going to happen, okay, because you can't get them both at the same time. So that would be 0. Here is another example. So this would be in kind of a real world scenario here. You have a rental car agency has 44 cars. Out of the 44 cars, 28 have GPS. 2 cars are selected at random. Find the probability both have GPS. Okay, so this one you have separate events, but these events do affect each other. So the first event, okay, and you don't have to go through the formula for this one. You can find the probabilities because we're given the numbers here. So the first event, I am going to randomly pick a car. I have a 28 out of 44 chance that car has GPS. The second event, how many cars are left? 43 cars are left. How many have GPS if the first one already did? 27. Okay, so this is what you're going to want to do for an example like this. So you multiply the probabilities. So I would do 28 times 27, and then 44 times 43, and then you have 756 divided by 1892.399, so 0.4. So I picked a car, okay, and I drove that one off the lot. So now the next person that gets a car, there's only 43 cars on the lot, and out of those 43 cars, only 27 of them had GPS because one of the cars left. All right, and that is 4.4.